Advertising. Woo! Advertising. I'm putting in 4 bars of this music. Maybe you know it from the Looper channel. You can buy the song too. I'm seeing if 4 bars will make any problem with YouTube later. Or Twitch. Isn't that brave? That's really brave. Also, I have to give a positive review here for a new keyboard that I just received. Very nice. I'm not going to bother with German stuff anymore. Very good. Very good. Boom. Gave some feedback. We are not going to use neural networks, but still make some AI. Today's a good stream. It's actually, this is not the one, forget it. This is the thing. Mental jam, it's my new word for just brainstorming little ideas. We just make up a language on the fly and make a logic bot that asks basic questions about itself. And this is the new code. No line counter here, but I'm sure it's not very long. Line 45. That's okay. 45 lines. And it's a new language we just make up. A combination of English, logic programming, some facts, and this roughly looks like a procedure with if then else. Really, if you want to make a workable AI, you need to combine ideas freely. That's what nobody has done before. Combining all these ideas into a streamlined system. There's going to be a lot of coding in this stream. So, some people like to watch coding in the background while they do some other brainy things, I assume. I watch chess in the background when I program. Not right now, though. So we just use the tools we have and attack this program. I mean, the purpose of the program, maybe you can guess it, is just the title. It's the computer discovers it has RAM, and by some general logic, this is all just general logic, nothing about the case in hand. By some general logic, it asks questions about itself. Like, how big is my RAM, and do I exist? No, it's about the RAM. It's just an example. And we make a new program. Gotta get used to the new keyboard. The end key is somewhere else again. They all have different layouts. Philosophy, but the name doesn't matter. Okay, we're done. Program done. Goodbye. Let's put the inputs directly in here. Oh, let's call it program. In my language JavaX, I have multi-line quotes, so I can just embed any text into the program, which is really useful. In Java, they're adding it now. I think Java 13 or even 14 will have multi-line quotes, probably not as elegant as these. This is from Lua, syntax from Lua. If you happen to have these 2 characters in your string, you can simply use this as a delimiter. And on the other end, obviously, it's going to be this. And if you happen to have, oh my god, the end key. If you happen to have this in your string, then you can use this. You can add equal signs until it's unique. You can't forget this, it looks so pretty. I like syntax that you just don't forget. So I copied this from Lua. I used to do a lot of Lua in some time. I made a whole OS, Lua OS, like a bit similar to the Java OS I have right now. I'm always doing this because it's not a complete OS, it's the upper layers of an OS. Be that as it may, here's our program. This is just a comment. I'll keep the Java comment syntax. Here we want to assert that the parser that we're just making finds patterns in here. This obviously reveals the pattern pretend something. Okay, enough rambling. How about we save this program? Nope. Philosophy but 1 and development. Check the volume levels, it looks okay. How about transpilation? Okay. How about loading the module? Okay, not okay. It needs a better base class. Blop. Load. Because we want to print some stuff for sure. And here we go. We take the program and we split it at empty lines. How do we split at empty lines in JavaX? Anyone? 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 Yeah, we say split at empty lines in CamelCase. So now we print this to see that it worked. I'm looking for a smart way to print this. How about we join again with empty lines. However, we indent all of these. We indent all of these with something fancy. To see if the splitting has worked. Okay, we see nothing. I think there's a stupid bug which is embarrassing to no end, which causes the printing to appear only in the log here. No, it's a different problem, but still. Indent. So I did the indentation wrong. Okay, let's look at the indent function. What do I have here? I think indent X is also the better one, with tiny but noticeable advantages. Here, this is the one I want. That should work. Tell me I'm right. Very little number, oh my god. Do something proper here. Okay, I need to make it like an icon here. I needed a direct transpilation button. Here! There we are. I think this was actually not the bug. Enter means we enter the scope of our module, so all our print statements go into the modules window or are associated to the module. Okay, this one, yeah. Let's check it out. One block, one block, one block, one block, one block, that's okay. Here, here, here. That's very good. Next thing is, these are multiple lines. We should find out that this is the case. These have to be processed individually. The other blocks are all a single entity. So it's a bit of a guesswork thing. How do we know We could try to find other things first, like find out this is a sort of logic rule. So we discard that, and this is a procedure. And everything that remains must be a list of facts. It's not totally good. I mean, I just like to be convenient for the user, not necessarily for the machine. Always a distinction. Also, I believe we have auto unindent because there's this indentation that we want to get rid of. How's Discord doing? It's all good. How about we auto unindent the whole thing? Not in the variable. And let's make this transient for not very interesting reasons. Also non-static. Auto unindent, do we have it? No, wait. Auto unindent. We have it. Oh, what an elegant function. Nah. Oh, come on, this is stupid. All the little details. So is it better? Is this unindented? No, it's not. What is happening? Auto unindent. So we want to make AI, and what we're doing now is indenting text, and you know, these are the base levels. You can't always choose to do all the amazing stuff. Sometimes you just chase little bugs. You know, we might want to move the auto unindent. Here. To each little block. Save. Yeah. Okay, step 1 done. So the idea is if all the lines are on the same level, it's not a procedure. We assume it's a bunch of facts. Man, this will be quite some long stream. I want to push this thing through here. The world needs this. Okay, we can comment some things. Step 1, split into paragraphs and unindent. Map auto unindent, split at empty lines, and we will have the paragraphs. And optionally we print the paragraphs. Paragraphs. Print the paragraphs. Step 1. Print got paragraphs. Print how many we got. Next step. Maybe we want to not bother with counting. Throw away comment only and quoted paragraphs. Assume it's a title. So paragraphs 2. We filter the anti-filter paragraphs. If it's quoted, we throw it away, and if it is it's single line, that's better. Or Java tokens. If there are no Java tokens, that's how I. If it's only a comment. Print got paragraphs 2 filtered paragraphs. Let's check it out. Really? I'm sure I have that. Count tokens. I'm using one single tokenizer for everything. I tokenize Java and JavaX and natural language with the same tokenizer. It's kind of magical. We make a synonym to the function because we adapt to the user instead of having the user adapt to us. If I want this function, I get this function. Got 11 filtered paragraphs from 12, so it dropped one of these, but it did not. It did not drop this part here, which I thought it would. Okay, count Java tokens. What's happening? Count Java tokens. Comment. More comment. What do we get? This is water today. My heart is complaining. I drink too much coffee. 0 tokens. Yeah, sure, there are no tokens. It's all a comment. So which one did we miss now? Which one did we miss? 12 paragraphs. Okay, this one is still in there. Okay. Yep. Nope. Happy hacking. Hack it until it works. Always the right strategy. Now we have it. Just simple spaces in the way. We threw away the title of the poem and we threw away the comments for now. So we have 10 paragraphs left. Oh, this one we also want to throw away. The titles in the text. Where is my the new keyword? Here. German layout. Ends with. Let's be really. It's rubbish. I know it's rubbish. It doesn't matter. It'll work for now. Got 12 paragraphs, got 9 filtered paragraphs. Okay, now we have the meat of the program here. And first of all, we can find out these facts. The idea was that if all the lines are unindented, it's a list of facts. So how about we create a function? All lines are unindented. Let's make it really simple here. For all lines, if it starts with a space, false. Otherwise, it is true. It's not really AI though. Not AI, but a good function. All lines are unindented. All systems operational. The end key. Oh no. Find fact paragraphs. True, 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 false. True, true, false, true. Is that correct? The fifth one. 1, 2, 3, 4. No, here. Where is it? 1, 2, 3, 4, 5. Okay, it's actually, yeah. This one has indentation. And this one has. Oh, the other just 1 line. Okay, got it. First of all, let's trim all of them at the end. Map R trim is what it's called. Well, let's even do that first. Okay. Connection refused. My server is doing shit. Okay, this part works. Oopsala. Not good. What happening? Connection refused. Holy moly, what is that? Where is my... Oh. Okay, not 100% sure why my server just stopped. That's not very good. Is it coming up? It's coming up. $79, $82. Come on. Oh, the visitor counter bot has gotten fat, apparently. Takes too long to load. Okay, there we are. Whatever happened there? Servers are so mysterious. Okay. Filter. A nice kind of function called filter anti-filter. You get the positive and the negative results using some predicate. And I think that's that. Facts and fact paragraphs and other paragraphs. If it's multi-fact paragraphs, and this. This unpair stuff. Do I even have it? This is a JavaX construct, and they are not always completely implemented for the complicated cases. It's... yeah. Nope. Oh man, my poster. Oh. Just a simple thing, we need the reversed argument order. Or will that be detected then? Let's see. We want Java to do the type magic. This lambda expression, yeah, I assume. Wait. Wait. It's not applicable. Why is it not applicable? Because I'm stupid. Now it is. Add facts. So now we add some facts. Let's have a list of facts here. And for now we just add it to the list. We can print something. Got fact. Facts. Facts are facts. Check it out. Okay, got a few facts. It's not, no, it's not completely right. Huh. I think, oh man, this is stupid. We're spending too much time with these parsing things. Okay, it's better, it's good actually. Now we have 6 facts of the program extracted. As a reminder, we are doing this here. This is a program in a newly invented language, like today, that makes computers think about their own properties. For example, their RAM sizes. Okay, now we process the other things. For example, these logic rules. I need some kind of setup here that is not killing my back. I think that's advantageous. So let's go on. Find logic rules. Paragraphs 3. Split at double arrow. So if it's logic rule, if it's a logic rule, it contains an arrow. If it doesn't, we add it to the list of things still to be done. So a logic rule is something like this. Time for some classes. Logic rule. Logic rule has a left-hand side. We will do records. However, they will have objects actually here. All the arguments. Logic rule has a left-hand side and a right-hand side. But we're not giving them a type because that's important for this kind of program. So the simple version puts yeah, just takes the left-hand side, right-hand side as a string. I'm getting used to this keyboard I just got today. Logic rules is not good. Okay, try it out. Got some facts, got some logic rules. Okay. Now we want to parse this left-hand side, definitely, because Is it a function? It is, but we want something different here. I need a name here, but the only name I can come up with is the name that exists already for the function we want to use, but we want to wrap it in another function because it does something else. Split at ampersand. I don't care, I just call it like this. And now we define this. And this is another function that actually takes object and, or no, it takes string and it returns object. This is so un-Java like, yeah, we should never just use raw objects. But this is a new kind of, it's a new programming style. Right? Okay, now check if this function actually is implemented the right way. No, it's not. This goes onto the string directly. But we need the tokenizing first. Split add tokens, exactly. This is a duplicate function. My browser is too big. Here. Split at ampersand. We have to make this function one time and then we can use it all the time. Boom. Created a new standard function. And we need a new record type, namely an AND. And left hand side, right hand side. They are they're not classically called left hand side and right hand side. What does it do if there's only one? Then you get this, right? If it's only one, return string. Otherwise, we return an AND. So we can return a string here and an object. That's the whole idea. We mix strings and objects and everything into like a tree structure. We do a very straightforward, simple, abstract syntax tree. We take the first one and then we parse again. It's not very efficient in case there are even more ampersands, and we have to join the stuff. But first, it's recursive. Now I'm curious if it's gonna work. What are you saying, computer? Computer, what are you saying? Oh yeah, I have to say new. In JavaX, sometimes I can say just the class name and it's automatically converted into a constructor call. Not in all the cases, sadly. Gucke mal. I slipped into German here. Ha. The left hand side has been transformed into this AND block. And this and this and this. That's pretty good. Next thing, maybe we have to find... Oh, maybe I should switch to coffee. We should find variables. In this program, in this sloppy new language I made up on the spot, x is a variable. Sorry, also a is a variable. I'm pretty lenient here. So we make a general assumption just for this program. It's okay, this is like in the lab. It's not the code we will ship. We're in the lab. Variables. Let's be extremely simple here. Make a case-insensitive set, and it contains a, x, and y. It would be stupid if there was a sentence with a. There is a sentence with a. Yeah, that's stupid. Also, it was just a bug. I meant x here. My program had a bug. So all the variables we have is x and, let's get rid of this one, x and y. My windows, there are too many windows. Ask. Lots of tiny little rules that make sense in some context. If the computer is about to ask something, but the answer is known, then it should not do this. This don't operator kills the intended action. That's the purpose of this rule here. And if there is a specific answer, then the answer is known. These are the little things that seem almost tautological to humans, but we need them for the engine to work. Because computers know nothing. They know nothing unless you teach them. So this is basically for two different things. This is for an input from the user. First idea was I say memory to the computer, and it should just think of probable things I meant. Maybe I want to know how much memory it has. And then later I thought, okay, I don't even need human input. I can just have the computer think. If the fact I have RAM is in its memory, then it can do something, and that's this rule here. I have x ask something about my x. So the computer asks things about itself. So why don't we make this here work? What is this? This is a logic rule. I told you it's going to be a long stream. This is a logic rule. Where's our parsed logic rule? I have x here. So what we need to do here is make this rule trigger on any fact. I have a class called all in all. No, all on all. That's a pretty cool class. I've never seen this before. If you have a set of tools and a set of objects and you want to use all the tools on all the objects, this class does it. And also later, you can only even need the object thing. Later you can add tools and you can add objects, and it will automatically do all the combinations that have not been done before. So the tools are the logic rules, and the objects are the facts. So this class, this is a simpler one where the objects don't change, just you add new objects. So this class will run all the logic rules on all the facts we have, yielding more facts, for example. So we do that next. Enough parsing for now, even though procedures are not parsed yet. And single line facts, whatever. Okay. How about we make think function? I love function names like that, it's just great. Function think. New all on all. Logic rule. And facts. Facts don't have a class yet, doesn't matter. Rules on facts. What can we do with the class here? New A and new B. Let's just change it. So we can add multiple at once. Ah, that's the keyword. So, just a convenience method. We could say new tools here and new A's and B's. The tools are called A's. Objects are called B's. Add the logic rules. Add the logic rules. And new B's. Oh, I need the function. I need that function. This is a for that accepts null, the null list. It's another little convenience thing. Capital O. And just for cosmetics, rename lists. It's alright. New B's, facts. And facts. And then we can see all the combinations that come out by using the next function. Isn't there an interface called producer in Java? Is that what we want here? We want an iterator, basically. Whatever. Pair. So tedious. Combination. So we apply all the logic rules to all the facts. Or we don't. Another JavaX syntax, while not null. Okay. Yeah, quite a few combinations. This should be correct. Logic rule 1 on fact 1, logic rule 2, fact 1. Most of these combinations will just fail, but it's already okay. We can optimize that later. Apply logic rule, logic BA to fact. So the rule has a left-hand side, which is either an AND or it I think I have to assign it first to a variable. I have a matching construct in JavaX. If the left-hand side is an AND, like this. Yeah, we want to see if the fact matches the first condition here. One might actually rewrite this like this: A and B, arrow C, might want to be rewritten into this. Yeah. I don't actually recall what the transformation is called. It's not currying, I guess. Similar to currying, but different. So, because this is, then we immediately have the first condition here. You always want to match the first condition, second condition, and we're done. So, the whole thing, let's just say it's to do. Oops. I mean, oops is really not what we want to hear, but I think I saw where it's coming from. No, I don't. Okay, where's your goddamn oops? Come on, what is that? If I just say fail in the program. Okay, I think, yeah. Okay. Okay, I wrote to do, but I mean I want it to work, so what am I doing here? Let's find the first condition. Remaining. Okay, now we match condition. With the fact. There is something called Gazelle zip. Let's see. That's a really nice function. Tokenizer. Okay, it has a tokenizer. It defaults to the right tokenizer. I think this is a beautiful function. Gazelle zip. Cond fact. And it gives you a mapping of the variables. No, of all the tokens, exactly. Gazelle zip. Let's see. Oh yeah, we assume the condition is a string at this point. See here. Here you know, this is the right one. I have x was the condition and I have ram is the fact. So x equals ram, everything else is unchanged. Here something wrong was matched. You can see that from the fact that not only a variable, x is a variable, is matched to something, but also actual words in the input have to be changed to match the fact, and that is just not right. So next we check if they, where am I? Maybe go away with the server here. Are only variables. Okay. No match. This is when the input is longer or shorter in terms of words than the condition. Print. We go through the map, and if all keys are in set. This is, I think, if we don't have this function, keys in. We should make another standard function. Nope, all keys are in set. Boolean. We have a map. Let's not bother with the types right now. It's quick and dirty. 4 keys in the map. If the set contains the key, we're happy. If not, we say this is false. All keys are in set. I watched a lot of the lockpicking lawyer lately, so I think keys are in my mind anyway. We have a fixed list of variables. Right, with non-variable changes. Exiting. Worst message ever. Now we have a proper mapping with the keys being variables. Match. Oh, come on. Variables or vars, whatever. Whatever. Good. These are thrown out, and we have one single match. I have RAM. What was the logic rule? The logic rule was, I have this, ask something about my x. So we're almost there. You know, like 10 minutes ago I thought this is never gonna finish. It's just way too big. All the logic matching, but now we're getting somewhere. Apply mapping to right hand side. Assume the right hand side is a string for now. And there must be something like apply var mapping. Apply I mean, actually we can simply just go through every token. And the specialty here is we should not honor these brackets. We should just go through word by word. This is a word, this is a word, this is a word, because the X otherwise would get lost. So there's two ways of tokenizing this. One way is to see this as one token, and the other way is to see this as one token, this and this and this and this. So we do the individual token thing, map code tokens. But there was something. Look up code tokens. Replace code tokens using map curly. Let's do the simple one right now. Good. Replaced. Placed. No autocomplete. Who knows? I really need an ergonomic chair. This is IKEA. Not the most expensive IKEA chair either. Are you still not happy, computer? What do you want from me? Consistency is what you want. Preciseness. Preciseness. Precision. Convert the tokenization back into a string. Boom! I predict it's gonna work. Here. There it is. This is the first thing I wanted to deduct. Ask something about my RAM. So that's the instruction for itself that the computer generated. So now the question is, do we distinguish between facts and instructions? I don't know, this is a new kind of logic engine that we make. So how do I know if we should, how do I know if I should distinguish between two things or if they are better in one list? Right, no. You know, facts look like this, blah has a blah, I have this blah. And instructions look like this with a verb. Ask something about whatever. If we do it really simply, we do it all the same way. Because this procedure should match on this here. So, how about we see this as a logic rule where a procedure comes out. We haven't even parsed the procedures yet, in fact. Okay, let me first say that this is a good result, what we just got here. The bot has deduced from the fact that it has RAM, it has deduced that it should ask something about my RAM. That's a good first result. Okay, what if we do this? What if we change our syntax here a little? Now this is a procedure. That's a good idea. It's a simple change, but suddenly the computer can make much more sense of it. Any more procedures? These are just actually logic rules. I like this idea, that's pretty good. I just have to copy this over to the program. I'm editing in two places, it's not so smart. Have I edited this? No, I don't think so. Okay, let's try this. Okay. So now we have more logic rules. Let's print what is unparsed in the end. It's called paragraphs 4. Is there anything we didn't parse? I think we parsed it all. Yeah. Otherwise it would print this here. It's raining, I think. Logical here. Okay. So, okay, the fact that was produced by our logic rule parsing done. Now think. Add as fact. And right away we yeah. Put this up here. And when we add a fact, we want to add it to this combinator object 2. Rules on facts, new b fact. You don't need this anymore. Because now we're going to do a second round, right? Where we have produced some facts in the first logic round, and from these new facts we will then generate more in the next logic round. Does that make any sense? I think it does. Round 1. Logic round. Yeah. Rule any change. This defaults to false. While this could be take forever though. We might, while licensed is my better version of while true. It allows the program to interrupt it, or the module to be while round whatever. Do 100 of those. Any change false. Any action. If we did anything in this round, we assume we should do it again until nothing happens anymore. If not any action, end this carousel. Wow, logic round 3, interesting. Okay, we do not have to print out all the combinations, that's just annoying. Where was it? Combination. Okay, yeah. Okay, better. Parsing, logic round 2. Okay, I think we are. What? Is it starting at logic round 2? It is. It is starting at round 2. No. Logic round 1. Okay, let's get rid of another print statement. Exiting. Just return quietly. Okay. Match. New facts. In Logic round 2, it actually does nothing. There's nothing to do right now. But shouldn't there be? Because ask something about my RAM. Yeah, it will. It should match with this procedure here, shouldn't it? It should match with the procedure to yield the procedure. Let's put this back in. Debugging with print statements. There are many ways to debug a program using a debugger or your print statements, and each have their merits. I do not have a debugger at my disposal right now because I have my own language in front of Java, so it's tricky to use a debugger. Sadly, but I don't really need it. Okay. Ask something about okay, there's a new fact, which is no, I have RAM was the original fact. We did add the fact, right? Come on. Did we? Got fact. Okay. After we apply the logic rule. Yeah, add as fact, and I didn't add as fact. But we should definitely make sure we also have another nice set. It's called linked CI set. It's case insensitive and it has an order. The elements are stored in order. It's a little set I made. Only if it's a new fact we will add it to the queue. Otherwise we might be in an endless loop. Okay, so now try to find anything in here. Ask. I'm getting hungry too. I should do something about that. Oh, here we have it. Got fact proc. We don't distinguish between facts and procedures. So here, this is good. Recall in the original text we had a procedure operating on X, and now this whole procedure has been rewritten to operate on my RAM. It's the instantiated procedure. I'm really hungry. Let's play the music again. We have the procedure, and what is it? It's a block with if then else and with a for loop. How long is this stream? 1 hour, 15 minutes. Let me turn on the light. Just a second. Back in the days where I had solar power at home, living off the grid, I could not have rendered long videos, I guess. Now I have normal electricity like everybody else, so I can do long videos. DSL we have too. Vodafone is providing us. Okay, so we want this procedure to be executed. How do we do that? Basically, we have it as a fact, and yeah. It's another rule, kind of. It's another all on all. Or even not, or I don't know. Let's be simple about it here. Let's parse the procedure. If hook. Okay. Yeah. Fact. Okay. To combine it with the rules, check if it's a procedure. We do it the manual, the pedestrian way. If it's two tokens, there's another way, but I forgot right now. If tokens, if it's 2 tokens and code token, and it's proc, and we do require the curly brackets for now. Is curly bracketed. Get token 1. What do I do? Over eager with the brackets. It's a procedure. It's a procedure. Procedures to run. I'm using very speaking names this time. Okay, on curly, I think it's gonna work. Da, da, da. Okay. Procedures to run. I'm not sure about this method. Does it exist? Guess it doesn't. That's a good method though. You should make it exist. I think I'm getting used to this keyboard. Nice. Boom. Count code tokens. Okay, count code tokens. Count tokens actually, just count tokens. But we're all humans, so we misremember sometimes. But from now on, the computer will adapt to us instead of us to the computer. Count code tokens. Yep. Got procedure. In case we haven't run it yet. That's the procedure body. Okay, got procedure. Yeah, we are combining imperative programming, if else for, with logic and English. It's a really cute little mixture. Proc. Combination. Got procedure here. If my RAM exists, blah 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 blah. This is getting somewhere. Very nice. Very, very nice. Maybe we throw away this combination. Printing. Okay. So next we have a procedure to execute. Got procedure. And we got only one. That's very good. So we go line by line, but we have to make sure. Yeah, I'm using Python style indentation here. As you can see, hopefully it's all spaces and no tabs, because tabs no good. I absolutely believe we should use spaces all the time. Spaces are better than tabs. Change my mind. Because tabs are always ambiguous. There's this 2 space tab, and there's a 4 space tab, and the 8 space tab. Use spaces and we're all happy. Oh yeah, I wanted to print it better. Got procedure. It's indented so I can see it better. Transpilation is so fast with these small programs. It's less than a second. Or at least when it fails. When it doesn't fail, it has to go, I don't know, whatever. Got procedure here, okay. It's not perfect though. See here? This else should be on the same level. Oh, that's pretty bad. How did that happen? First of all, what does uncurly do? Drops the spacing. Well, we need these spaces because we are in the Pythonesque indentation world. Keep spaces. Keep spaces in beginning and end. Yeah, let's make a shorter name for it right away. Synonym uncurly keeps spaces. Got procedure. Uncurly keeps spaces. Here. But now, okay, now that was grab. First two and last two, and let me betcha this function is not going to exist. Oh, no, it is. It does exist. Okay. Finally, there's a blank line at the beginning, nobody cares. But then we have this properly indented. So how do we parse it? We have to merge these things first. Merge this with this line with this line, and these two lines with this one. So we basically do a split whenever something is indented. Yeah, that might do it. Run procedure. For all procedures, get and clear list. We run the procedure. Print running running procedure. Auto unindent. And yeah. So we unindented all to the beginning of the line, but we keep the relative. No, it did not. Are you kidding me? We do want to drop empty lines. Nope. Do we have this without empty lines? I cannot trim the whole thing because of the indentation problem. Or can I? No, I cannot. Without lines empty after trim. I actually know how to make this function. No, I don't. Yes, I do. Okay, first convert to lines. Filter. Empty after trim. So now we have the non-empty lines. Possibly our trim. You don't have to understand this, it doesn't matter. This should do it. get rid of any empty lines so we can run the procedure. Okay. I should put like a map on the screen where we are in the project. Make a philosophy bot is the main topic. Subtopic is make procedures work. Got procedure and still it's not. Are you effing kidding me? It should get rid of this first empty thing here. Why doesn't it do that? Empty after trim. Go to the eval. I have Java eval. I can just evaluate code. And this looks really good. What's happening with the other one? Holy moly. That's what we're fighting with, spaces and line breaks. You know, that's the level. Okay, it starts with a line break. Okay, let's simulate that. Okay, and now I want this to work. I want to go on, man. I don't want to spend all my time with line breaks and spaces. I just don't. Here, what are we doing? Live, yeah. Maybe this auto unindent is doing some fancy crap. No, it's actually not. What? Oh, it's happening. I'm sorry. I need more edges. Okay, this is ready to parse. I don't know what I was chasing right there. This is all fine. Whatever. Okay. Let's search for Python in my repository. Python to Java talk. Python to Java talk. Oh, converts the comments. Okay, it's nice, but not what I want. Let's search for Python and indent. Nope. Colon and indent. Nope. So we don't have a function yet that takes this and finds out what belongs to what in terms of indenting. So we invent a new function. Python style indents. Group Python style indents. Good enough. And let's say this converts to a list of things. Let's call it unpythonized. That's a cool new function. No. After we make this function, we will be able, in any program we make, to use this kind of indentation to group things, because it's just elegant. Unpythonized. Group Python style indents. Maybe a little comment is not bad here. E.g. A list with 2 elements. Okay, enough of a comment. Let's get started. We convert it to lines. I'm already like, if you code for too long, things begin to float on the screen. Get indent. We don't even care. All that matters is if its input has to be starting at column 1. Call auto indent if I'm sure. All that matters is if there's a space in the beginning of a line. And conveniently, the isSpace function also covers tabs. So even if you use tabs, we are okay. Starts with space. Indented. Yeah, if it's not indented, we dump what we have. Start of block 0. If it's not indented, if there's anything to dump, we dump it. Sublist lines. If you like to do stuff like this, if you say, oh wow, this is great, I want to do this, to write functions where every little character has to be correct and the whole logic has to be correct, and you have to think of 1 million things, and if you do that correctly, you have successfully programmed something. If you want that, then you should be a programmer. If you look at this and you're like, what is this, and this is way too complicated, you don't want to be a programmer. It's Artron. And we mark the new block as beginning here. If it is indented, in fact, I think we do nothing. Just continue. And in the end, it's a typical style of loop. In the end, we emit the last block. If start of block is what the heck. You could do something very elegant here. Add if empty. Add if not empty. Then we can get rid of this if altogether. Yepa. Haisasa. Same here. If it's empty, it will be empty and not added. Nice new function. Place your bets now. It compiles. Unpythonized. Let's check it out. Unpythonized 1, 2, 3. It means these are the 3 statements. It works. If this, else this. Slight problem, else kind of needs to go in with this if. They really do belong together. Just it's not obvious from the indentation. It's not something this general parsing function would pick up. But we can do it here. Group else with if. And also we just want to convert this into an object. This will be an if-else object, if-then-else object. This will be a for object. Clearly we want that. If condition branch 2, then else. Is it a keyword? It's a keyword. Else block, then block, else block. We need an for statement. What does it have? Yeah, this is a nice little syntax, also like Python or any other language. It has a variable and it has a statement, and we want all the variables where the statement holds. For, let's do it like this, for variable condition, and we all these are all objects actually. Variable is maybe not, I don't know, let's all make them objects. Condition and book. Good. Oh, it's called body, I guess. I don't care either way. Body I think is better. First we parse the procedure. Yeah, new out. Parsed procedure. What have we got? Either we have a normal statement, or we have an if, or we have an for. Brackets. First code token. If it's an if, new if, We want a colon in the end, and we want it to be 3 tokens because the middle token is the condition. No, it's actually bullshit. Sorry. We get the whole thing. Yeah, this was nonsense. This is correct. Okay, the condition is just the second token. The round bracket. Throw away the round brackets. And yes, we have sublist talk. I think that's it. Phew. Phew. Ergonomic chair. Where's my ergonomic chair? Yeah, bullshit. Once again, we output strings if it's an unknown command and or objects. We just mix strings and objects. It's one of the ideas in this little exercise. Let me guess, it's called first token. Yes, it is. But this time I want to call it first code token. Oh, hello. First code token. Huh? Oh, okay, yeah. Okay. If it's already tokenized, it's easy to get the first token. Parse procedure. Okay, here, this is the new if object. This is the condition. Okay, the colon needs to go away. Yeah, that's pretty neat. That's pretty good. And let's right away move on with the else. Okay, last. If there was no if before, we are really confused. If last. It's not an if. Else without if. So we do have an if, we assert there's a colon, oops, and we cast to an if, and we set the else block. Yay! Ha! Ha! Now we have parsed if else. No, we have not. Dear computer, why are you not happy? Oh, this slash doesn't work. Oh yeah, okay. Java X magic. As I said, with complicated cases, sometimes constructs don't fire. Okie dokie. Okay, Yes, the else has one token less because there's no condition. See here, if, then, else. It's parsed. Now we need to parse the for statement, and we are almost done. Maybe we make it easier for ourselves. These extra brackets here, is that easier? No, it's not really easier. No. Nope. Let's keep the brackets. If it's a for statement, we assert the colon as usual. We extract the condition. And we have the for body. Okay, we need the variable, we need the actual condition. Condition looks like this. So we unbracket. And we assert the vertical bar. And we assert there's an identifier. Assert get code token. The first one. Now we have the variable, and the actual condition is just the rest of the condition. Yup. Ooh. No. So our little programming language takes shape. Actual condition. Okay, this condition is wrong, but we're close. We are close. Yep. Nothing to worry about. For y in, my RAM has a y. My RAM has a y almost. This. Okay. This should be it. For y in, my RAM has a y. Assume that this exists. X asks something about. There's this double my in there. See, my RAM. That has to be wrong. Is it in the program? It asks something about X. It's true. It doesn't make sense. It asks something about X. X has a y, the y of X. This is the correct version. Okay, assume the y of my RAM exists. Y still has to be determined, and y is size. The size of my RAM. As a recap, the bot is supposed to find out it has RAM and ask sensible questions about it. I have RAM. And because RAM has a size, which is a fact in database, the bot will ask about the size of its RAM. This is what all these procedures do, which are almost English. Like English plus a bit of Python. Not really Python. Just some logic. It's math. As I said, it's a mixture of everything. Mixture of imperative programming and math and English. So we want to run this procedure now. Yeah. So basically what we called run procedure was actually parse procedure. Parse procedure. Program. Parse, not program. Commands. For commands. For commands. What is it? Is it an if? We can use a nice Java X syntax here for record matching. If condition, then block, else block. Unknown command. If condition block. What is our condition? our condition is my RAM exists. It's actually something it doesn't know. So we could add that actually to the program as a logic rule. Why don't we do that? I have X, my X exists. Oh yeah, but I did it in the wrong file. My X exists. I think now we should have the fact my RAM exists. Oh, okay. Nope, what's happening? I think this meshing thing doesn't work because we have some... because they're not static. Let's try again with static. Nope. Okay, I have to use this object. O means object in JavaX, because O has 1 character and object has 6 characters. I'm curious if the fact has been deduced. Got fact, I have RAM. I have X, my X exists. Did it do that? Logic rule. Oh, okay. Yeah. The parser is not as smart. We can do that too. It's not a problem. Later. Here, got fact, my RAM exists. I have RAM means my RAM exists. Obviously true. It says running procedure, it doesn't fail. Shouldn't it fail? Because it has unknown commands. It should fail, clearly. Run procedure. Have commands. Oh, come on. And commands. It's just for making a nice output. If it's 1 command, it should say 1 command. If it is 2, it should say commands. If it's 0, it should also say commands. So that's what this function does. Yep. How many commands do we have? 2 commands. Oh, it does fail, but the failure goes into the other window. Okay. Block to run. Check condition. For checking a condition, we just check the facts. Is it in the facts? Cool. For now. In fact, we should run the procedures later, I guess. Oh, whatever. And we just say one procedure just right here. Block to run. Hello. Run procedure. Okay, run parse procedure. As it is already parsed. Whatever. Yeah, it's not perfect. Whatever. Like this. Okay, parse procedure. Okay. Unknown command asks what is my RAM. The thing is, if it's an unknown command, we assume it's a fact. Because in the source code we can mix freely between statements in English and constructs like for and if and else. So anything that's not a programming statement construct is just a fact. Add fact. Sorry. Yeah. This deprives us of the detection of syntax errors, probably, some of them anyway. Because anything goes, anything is a fact. Facts, trim facts, if empty facts do nothing. Another JavaX construct, cast. It's instance of, and it magically casts the variable inside the block. Okay, look here. Got fact. Print here. Print what is my RAM. That's the first thing it should do. What is my RAM? Print. and then it reacts to input which is not implemented. So the first thing done because it has a fact that says it has RAM. So there's that. And now the for loop. Yeah, it went into the right if branch. If my RAM exists, and it knows it does because it has some, it says, what is my RAM? Nice philosophical question. Now we want the detailed question about the size of the RAM. Now this should fire. Is that a money stack overflow? Maybe an old video of mine, that would be my guess. In an old video I made something funny. I think. No, it's a different thing. I forgot. I don't know what it is. Or I can't even know. Only saw the comment, not the video. So we want to execute the for loop, or yeah. It's the last thing we do in this stream, I think. Run the for loop. Command is an if. Fail unimplemented command. If it's not null. So if command is a for has a variable, it has a condition, and it has a body. Wasn't that right? For var condition body. So what do we do here? In the end we will do something like this. And first we have to find all the matches. Where are we? Got procedure print. Running procedure. We have multiple sub-procedures now. So where are we? If here we are. For my RAM has a y, and with y is the variable. Let's check the program again. We know that RAM has a size. We do not yet know that my RAM has a size too. X has a Y, then my X has a Y. But this would be an endless loop, I think. And my X exists. That sounds better. But do we have rules with two conditions yet? Have we implemented that? Remaining, we have not. Apply mapping to remaining condition. If we have a remaining condition. If we don't, we add the fact. Else we recurse. condition replaced. Hello. We make a new logic rule. No, we don't apply it, we just add it. Add logic rule. We add a new rule, exactly. Add a new rule with the remaining. Remaining replaced. And the right hand side. Yes. Yeah. We don't have the add logic rule function. So let's add it. Add logic rule. Add this, and this will also be a set now. Logic rules, that's good for now. Rules add. Convert to this. Get rid of this. Check if we're done. There we are. Let's be brave. Let's fail. Let's be very anal here. Bad hygiene 9.3. No problem. No problem. Now we should have a new fact. What was it? My RAM has a size. That was the... Yep. Yes, Java, I want to initialize to null. What else do you think? Do we have the fact my RAM has a size? Oh, we have it. Wow. My RAM has a size. Because it's RAM, and RAM has a size. Remember, we are all doing this from... Oops. We are all doing this from this kind of program. This rule has just been executed successfully. We are getting close. Now just for the for statement. We ignore the variable for now because we just assume it's one of the typical variables that we have declared here. It's just x or y. So all we need is a condition. So we need to match the condition against the facts. How do we do that? We could actually just make a new logic rule. Yeah. Where's the for loop? Here. For. Yeah, that would work, I think. We just add the whole thing as a new logic rule, the whole body of the for statement. Okay. Make a new logic rule and add it. We do not actually run anything here. We just say add logic rule, new logic rule. And on the left side there is simply the condition. The other variables have already been replaced. We do like eager variable replacement. Never mind. Is this all there is? I think it is. You have this here, so we just make the new rule. This to procedure, and then this here. Yeah. I think that works. That was surprisingly simple. Assume the variable is globally declared. Declared as a variable. Oh, almost done. Procedure. Proc. Let's make a nice line break here. Line break. Huh. Hi. Will this work? Logic round 6. We are reaching higher logic rounds. More logic rounds. I think it did it, man. It did. Wow. Here's the 4. Got procedure, got fact, got logic rule. Where is it? Here. Move the print up there. Got logic rule. Please. I think it did it. It's already asking about the size of my RAM. Now it should ask about the size of its RAM, because RAM has a size as per the facts database. Here, got logic rule. This is the size of my RAM. No, okay, this is going even one level deeper than I intended, but it doesn't matter. The size of my RAM. Okay, we should gather all the facts in the end. After all the logic rounds, let's print all the facts. We're done logicking. Logicking. So print all the facts gathered. PNL with heading, all facts, original and made facts. These are the facts we have put in. We should drop these, I think, in the output. So procedure is now a fact. I mean, these are all boring. Let's sanitize the facts. Facts to print. List minus list, I think it exists. Where do we have the original facts? Okay, original facts. The facts from the program, we don't want to print them again. That's boring. Turn in set original facts. We subtract the original facts and we say filter this. This procedure. Where's the procedure parser? Okay. Maybe we should not have put the procedures in with the other facts. That's kind of stupid. Yeah. No, we just take them out here. It's a lot better. Check if it's a procedure. If it's not a procedure, let's see. Oh, it's keyboards. It's in fact not a procedure. So we don't have to take it out in the end. But boom, also we save time. It's more efficient. Not matching on procedures when all we want is facts. Where is it in the original? What? Computer, my code is perfect. You must be in error. Okay, I take it back. No, actually not all facts. Facts I deduced. What are the procedures still doing in here? Are you kidding me? Add fact. What if we get the procedure twice? Doesn't matter. Good. Better. Memory can mean RAM. This is one of the original facts, however. Classic bug. Of course, who guessed it? Yes, we need to clone this. Clone set. Still not right, are you kidding me? Better. It deduced it should ask something about its RAM. It deduced its RAM exists. Its RAM exists. It deduced that its RAM has a size. It asks, what is my RAM? Which means printing. Ask and print are two different functions here. If somebody answers and it's a valid answer to the question the AI asked, it should store the answer to that question. Unimplemented, but logical. It assumes that the size of its RAM exists because its RAM has a size. It should ask something about the size of my RAM, and then it asks, does the size of my RAM exist? Okay, that's the last little bug, because it does exist. I believe we are just doing it in the wrong order. This is the last tiny bug. This is all that I wanted the program to do. It asked the right questions, starting out just from these facts. Oops. However, it's, I think, asking a question before it has the answer. Here we run procedures, and here we do logic things, and I think we should just complete these and then do this. So do some logic. If do some logic, any action, yes. And also here we say, if we run a procedure, it was an action. Right, so we know we have to do stuff again. I believe that makes some sense. Do some logic. We have another variable here. Where's the delete in this new keyword here? Turn this. And we just do this. And we increment the rounds, actually. This is bad. Round. I know, what is it? Okay, the counting will be wrong. Don't care. And this should return 0. Maybe this does the trick. This last little problem. Maybe. Better. Logic round 100. Maybe it's a bug. Okay, actually this is assume something, but assume is never handled. What does assume mean? Let's say assume just means, assume x just means x is a fact. How about that? And I'm curious about these 100 logic rules rounds. What's happened here? Okay. That could be the thing now. This might work. Assume the size of my RAM exists. The size of my RAM exists. And there's just a little thing. Did you notice there's brackets around here? These brackets are not right. At some place, somewhere, I believe here, so we want to do it. Drop round brackets. So these round brackets should go away. They do. My RAM has a size. No, now something is wrong here. Before it used to work better, didn't it? Let's do it here. Here. Yeah. My RAM exists, blah blah. And here, the size of my RAM exists, because RAMs have a size. So it doesn't ask, does the size exist? Which is a stupid question. But it asks, what is the size of my RAM? And that's exactly what I wanted. We can do the final pretty printing to actually have the question printed. Print the actual output. I need to find the right parsing function. Let's do it the manual way for now. If it says print, actual output, because the bot shouldn't print all the facts in the end. If it's a real bot, it shouldn't. This is the debug output, all the assumptions and whatever it did. Whatever it deduced, and it should print the actual questions. Output and the round brackets. Boom. Boom. Output and output, and let's check it out. Boom. What is my RAM? What is the size of my RAM? The first question is a bit generic, but the second question is exactly what I wanted it to do. Let's do one final touch here. Make the picture prettier. Drop brackets. I'm sure we have this. Drop curly brackets. I don't normally do this. If stuff is in round brackets, I drop the stuff also, like it's an optional part of the sentence, but not the contents of brackets. In this case, the brackets are for grouping. I normally use curly brackets for everywhere here, but curly brackets are a bit technical. So we use round brackets like normal people do. And I just made it wrong here. Round brackets. Oof. Drop round brackets. For the user, we print without all the round brackets. And I think that's it. I have to buy this song. I love it. $49. What is my RAM? What is the size of my RAM? And that was what I wanted to do today. We have a philosophy bot. I don't know if I had any viewers here. How long is the stream? Wow, 2 hours and 43 minutes. But the result is successful. Let's look at the code size. 300 lines and the actual input program. 60 lines. So this is a complete logic engine. We just made a logic engine today. Here. In one session. It executes logic rules and procedures and if and else and for. And it really finds out some stuff. We can be satisfied, ladies and gentlemen. Bye bye.